footage is for this spacewalk then. The first astronaut coming out, you see, is Mr. Ye Guangfu there, and he will be tethered to that robotic arm for this mission.
Right.
And we are also learning that there are two complete new tasks they have never tried before. The first one is to try another different operation spot. They used to be tethered on that robotic arm and work from there, right? And this time they will try to install that foot restraint onto the surface of the space station. I mean, how difficult is that?
I mean, it's never been tried before, so that's, I guess, it's difficult. But it's just one of those things. If you have time, if you have the chance, you want to test out. You want to be able to work as flexibly as possible because things happen on the space station. For example, the International Space Station, just a few months ago, there was a hole discovered in one of the capsules in the Russian section. And an astronaut had to go out and use a knife to attack the space station, really slash it open and tear away all the insulations and find the hole on the outside. So that kind of things, it's not something you can plan for. Right. So being able to be flexible, being able to get a feel of how to work on the outside safely, because it's very different. When you push on something, it's not just you're moving the other option, you spin in the opposite direction as well.
Right.
Right. So all these different other tasks, if you're familiar with how that works, that would save your life and also save the task. So in the future, so the more you test, the better, basically.
The more they learn, the more experience they can gather. And another task they will try this time is to move an object into a position without the use of the robotic arm, just them to themselves, relying on the help from each other.
Right.
And that's also crucial because they're only the two who are out there. They have to sort of rely on each other blindly because anything could happen, and the other teammate is the only person that you can rely on.
Yeah. So they have to trust each other, and they have to know how each other works. Once you're inside the spacesuit, it's very difficult to move around. That thing is pressurized. Just imagine yourself inside. Just have a glove, blow it up, and try to move your finger inside of it. The glove doesn't move with your finger, right? And then once the pressure is too high, imagine a car tire. If you give too much pressure, the whole thing becomes really hard. Right. It doesn't move. So it's actually very strenuous when you try to move inside. And then you need to not only, when you're moving something with the other guy, you need to know how you should move. You need to anticipate how he moves. And this whole thing, it's something that you can't really test out on Earth. And you want that sort of parameter to be input in your modeling, your understanding. How quickly can you move stuff around, right? I mean, how much oxygen, if any emergency repair needs to be done when the robotic arm goes down. Well, ideally, you should have robotic arms do everything, right? You should attach robotic hands on the robotic arms so that people don't even need to go out. You can just put on a VR set and control everything from the inside. But, you know, humans are still a lot more reliable than machine at this particular time. So this is the kind of things that they need to do. Yeah.
And for the last spacewalk, each of the astronauts were assigned different tasks, right? They tested the robotic arms, they fixed camera positions, they tested a new spacesuit. And this time, how are the tasks being assigned? You earlier mentioned, before it came on live, that Jia Zhigang will be crawling and Ye Guangfu will be operating on the robotic arm. Is that right?
I think that's what's going to happen. Do we have footage yet? But
We're
anyway,
still standing by for
I may
that.
be proven wrong very instantly.
Okay, we are getting the
TV,
exclusive footage now. Yeah. You can see this is from the helmet camera, I believe. Oh, this is not from the helmet camera. This one is from the helmet camera, showing you their perspective of what is happening around them, what they're doing. That orange rope you just saw was the safety tether, right? In space, you have to be tethered all the time to prevent from drifting away. So that is the first astronaut going out. I believe that's Ye Guangfu wearing that yellow striped suit out there. All right, our connection isn't that stable.
Right. So the first one out is usually the one that gets on the robotic arm, because when you are out there, when you try to attach your feet onto the robotic arm, you can't actually see your feet. Your helmet doesn't actually move. You move inside the helmet, right? You can't really see yourself. You can feel it. So the other guy inside will tell you, move your foot 2 feet to the left and that sort of thing. So I was.
Wow. So I
guess
don't
it's
think a
pretty
lot of
good,
people
yeah.
realize this because after you put on a suit, oh, once again, this is the footage coming from the space station. I believe this is Ye Guangfu coming out of the airlock. That is the position where they will be exiting the space station. And on the left is the robotic arm. Oh, that's an iconic image there, waving to the camera. I believe we'll be hearing a round of applause from the ground crew very soon. And on your right, you can see that is the working station, right? That almost look like a steel shelf. That is where the devices, the tools will be hooked onto.
Right.
And momentarily after Ye Guangfu is out, Zhai Zhigang will be following his steps and making his way out.
Yeah, I just want to mention how great the cameras are. I mean,
Yeah.
the sun is right behind him, and he's getting a full picture. He's not all dark. It's right.
That's incredible. That's incredible because they will be moving through different time zones. So from dark to brightness, from brightness to dark, right?
Every 90 minutes.
Every 90 minutes.
Yeah, so it's pretty crazy. That's why so when you're facing the sun, it's 200 degrees Celsius, something like that. And then when you're in the dark, it's minus 100 something. So it gets really hot and cold. That's why your spacesuit, the insulation on the heat insulation on a spacesuit is extreme, which also means when you're doing really hard work, like I said, you're trying to move that thing, it's hard. Then you generate a lot of body heat, and that doesn't get carried away. That's why they're wearing those, I don't know the footage, probably, if you remember the last few.
They will be wearing another layer of liquid cooling.
Exactly, the mesh thing, the blue mesh thing.
Suit underneath.
Just to cool them down, otherwise they're going to lose a lot of water. They're going to dehydrate really badly.
Right, because that spacesuit is completely sealed and it cannot dissipate body heat, right? So the temperature of the astronaut will keep rising and rising, and without a significant cooling mechanism, that could eventually turn deadly.
Turn deadly, and also the water vapor when it gets on your face, the glass shield, it fogs it up. So there is anti-fogging liquid that they have to apply, and if you drink your water and you cough on that thing, and water hits that splashback in your eye, then it's a whole disaster because you can't wipe your eyes. You're inside the helmet. So you have to keep your eyes open. You're basically blind, right, for a long time. So that has happened in the past. So all these sort of things, every time we watch, it's all fun and games. It's just Michelin guy and Michelin girl just floating out there. But for them, every time it's a huge adventure and pretty risky as well.
Yeah, there are so many things that could go wrong. Despite how cool, how fun it sounds, this could be one of the most dangerous missions that an astronaut could ever perform.
Yeah, so that's why they cram so many missions, and a lot of missions. It's just testing the emergency escape procedure, that sort of things. It sounds boring to us, but for the space program to be successful, that is, you can't circumvent it. That's in some ways more important than anything. Yeah.
It's fundamental for a successful mission. All right, we're going to have to leave it there. That's going to do it for this short edition of World Today. Of course, we'll be watching the special spacewalk coverage for you coming right up on China 24, so do stay with us. We'll be right back. We'll be taking a close look at the mission today in our show. And I'm joined in the studio by Professor Zhang Fan. He's an associate professor in the Department of Astronomy at Beijing Normal University. Professor Zhang will share with us insights into China's space endeavors later. But first, let's see what the second spacewalk about. Now, Zhai Zhigang and Ye Guangfu are performing extravehicular activities, and this time, Wang Yaping is supporting them from inside. This is her second time in space. The crew carried out their first spacewalk last month and completed a series of tasks. They have been working and living in orbit since October 16th. And in their 6-month stay, they will conduct several spacewalks and a series of scientific experiments. They're also conducting in-orbit training programs, including emergency evacuation and medical rescue exercises. 2 weeks ago, the crew gave a science lesson from the space station to Chinese students. And for the very latest on this, let's go live to our reporter Sun Ye. Great to have you with us this hour, Sun Ye. Now tell us more about the spacewalk. What is the operation about?
Hey, Chouyuan, it's about an hour since we last talked, and a lot have happened. I'm not sure if you've caught it. The other taikonaut, Zhai Zhigang, he has came out of core module just now, and he was reporting and talking with the ground control. They were just saying how beautiful the camera have caught up the image of the space. But let's back up a little. So the two taikonauts are both out, and when the two came out, both had said that now famous mantra, "I am out, I feel fine." And after both came out, they all had a hard-earned 15-minute break before the operation resumed just now. So that break is really necessary because they have a long night ahead. We have both come to be quite familiar with the spacewalk timeline for Chinese taikonauts. It will be around 7 or 8 hours long, and they're going to be doing some hard, arduous work. And this time, there are some tasks that we've come to be familiar with too. In the first place, they will be lifting a panoramic camera, and they're going to also install a key component for China's mighty robotic arm. Okay. So I hope you got it too. Just now, Taikonaut Jaguar made a joke. I'll try to tell you later about it. But again, back to what they were doing this time. They are going to install a key component for China's mighty robotic arm. They are also going to crawl on the surface of Tianhe core module as they've done before, and some other routine work. But what's different this time is that they're going to be fine-tuning their movements. They are going to be much, much more precise than before, as also the improvement for previous spacewalking experiences. And they're also going to test out on a collaboration kind of experiment for the taikonauts. So a long night ahead, and we will keep you posted. Chouyuan.
The beautiful view we've got there, the panoramic view, right, showing you the blue planet underneath, just breathtaking. So yeah. Now, the China space station is one of the country's most challenging and sophisticated space endeavors, right? What role will it play when it's completed?
Right. That's a huge question, but we do know, we have come to be calling the space station that is still taking shape China's home in space, their space home. And this is going to be a permanent station for China for at least the next 10 years. And China's space station, it is confirmed to be complete. The whole construction will be completed in 2022. So we have a lot to be looking forward to the next year. Chouyuan.
Thank you very much, Sun Ye, joining us live there in Beijing. And for more insights and perspectives, let me bring in my guest, Professor Zhang Fan. He's an associate professor in the Department of Astronomy at Beijing Normal University. Thank you so much for joining us. So as Sun Ye just mentioned, 3 major tasks for this spacewalk. First one, lifting up one of the cameras, panoramic cameras. They did it before with camera A, camera D. I believe they're lifting up camera C this time. We've got 4 panoramic camera installed outside the core module, I believe. 2 other new mission. One is to install another key component, I believe is the foot restraint onto the exterior surface of the space station. Another one, as Sun Ye mentioned, is a collaboration project. They will have to work with each other without the help of a robotic arm to move something to a designated location. how significant is this spacewalk? I mean, all the engineers, they always say that this spacewalk is setting the stage for the next one and for the next important task. How significant is this one? What is this spacewalk setting the stage for?
Right. So Zhaijigang just cracked the joke earlier, right? Let's see after 6, 7 hours whether he's still going to be able to do it. So this time, clearly, the ground crew is trying to push them, let them do the very physical, the collaboration thing, moving stuff around on the space station, crawling on the space station. They're trying to test what's the limit of the astronauts' capabilities when emergencies do occur. So this sort of things, it's a long checklist of the input that the ground design teams they need to be able to know. But these are the parameters in their modeling. When they design the procedures, when they try to build something, they have to have redundancies. Especially for the Chinese space program, they always have extra redundancies on top of redundancies, and this are the parameters.
This is the earlier footage of the spacewalk. That is, the astronauts, the critical moment of them opening the hatch of the airlock, right? And He Fu is the first astronaut going out to space this time around. And this is the helmet camera showing you a first point of view perspective of what is happening around them. Just an incredible shot out there. You can see their hands and the safety tether in orange. They're holding on to the handrail. And you earlier mentioned when they get into that suit, their view gets limited somehow, right? They cannot see their feet like we do. Oh, iconic image out there. A round of applause from the ground crew. Back to what I was saying, their view gets limited. They cannot see their side like we can just turn and see. They cannot see their feet like we can just bend down.
Right.
So they have to rely on the help of their colleague. And also they were wearing this small mirror on their wrist, right?
Yeah, because they can't turn around, they can't reach anything behind them or anything like that, yeah.
And just talk to us, how difficult is it to move in that spacesuit? I mean, that spacesuit is weighing about 125 kilos. Just imagine how difficult to move inside it.
Right, so it's the thing, the rigidity that really makes things a lot more difficult. The pressure inside the spacesuit is 40% of the atmospheric pressure for China. For the US, it's even less. It's 30%. It's even harder. It's like the top of the Mount Everest for you. And the reason why that happens is because if you put too much pressure on it, the whole thing becomes very rigid. It's like a tire fully inflated and pressurized. So for future generations of spacesuits, they'll have more sort of metallic joints that can just slide around. Then the rigidity become less of a problem. So the Chinese spacesuit is already halfway there. So each arm you have 3 different joints that just have rings of metal just attached to each other, so you can rotate them quite easily. But still, it's quite intensive work when you're actually in there. You can't see them because they're all fluffy and fat when you look from the outside. But it's a constant struggle. You will become more like a medieval time armor, and you have to push against, fight against, just to make it move in the way you want it to every time.
But despite the difficulty, right, that suit is providing crucial protection shield for them when they're out there in space, right? Talk to us. The danger that they will be facing when they're exposed in space. You earlier mentioned the temperature difference, right? They could easily range from 100 degrees Celsius to minus 100 degrees Celsius, depending on which location they're at.
Right. So if the temperature insulation fails, obviously you'll burn to death. Well, let's just not mince words. I'll scare you. Yeah. So the current pressure in there is 40% of the atmospheric pressure. If it drops, if the suit punctures, it drops to 7%. Then water, including your blood, will boil at body temperature, which means your blood will boil inside of you. That's how you die. That's not. So in sci-fi movies, your eyes popping out. That's not.
Yeah, that's not a pleasant way to.
Yeah. So that's bad enough. But the most dangerous thing, obviously you can float into space. Then that's actually probably the worst, because you'll be alive for like 7 or 8 hours and knowing that there's no way back. But the actual most likely danger is from solar flares. Right. the sun for us is safe and warm because we hide behind an atmosphere and also the magnetic field, but they're also inside the magnetic field. But they don't have the atmosphere, Earth's atmosphere, to protect them from harmful radiation from the sun. To them, the sun really behaves like an exposed nuclear reactor core, constantly blasting them with extremely dangerous stuff. So the space station, the hard shell, can provide some protection, but their suit doesn't. Their suit just have some lithium reflective coating. It's minimal protection. So if there's a solar flare, they have to quickly get back inside and hide. Otherwise, they're going to get lethal dosage or develop cancer later on. So that's the most likely danger. And actually, last crew, the Shenzhou 12 mission, one of the spacewalks, they had to hide inside for a little while because of abnormal sort of radiation levels. Yeah.
So the high radiation in space is posing another risk as well. But that suit is like a mini flying unit, right? It's providing their life support. It's providing communication lines to them. You can actually drink waters from your suit.
Yeah, there's a little
straw
thing.
Installed.
Yeah. There's supposedly food as well, but I don't think people actually use that. They eat before
I mean,
they
it's
go
a
in.
super long mission, right? It lasts about 6, 7, 8 hours. And
Right. So the oxygen supply, the normal supply is for 8 hours. There's 1.5 hours of miscellaneous extras they can do, and then half an hour of extra getting back time. So in total, you can probably stretch to 10 hours, depending on how much work you do and how much extra you burn. Usually for safety, they plan these things for 6 and 7 hours. So plenty of safety margins.
right.
Yeah.
And will they be wearing diapers for this spacewalk?
Yeah, sure.
I guess, right?
Yeah.
For such a long mission as well.
Yeah. Well, in the past, they have things that go into places where to collect stuff, but it's not as comfortable as the diapers. They don't actually want to use the diapers, at least from what I read, is that they try to not go. For water, they don't really drink gallons of water just before going out, so yeah.
I've learned that before they go out for a spacewalk, they would choose to have some food that's high in calorie, but low in fiber, less likely to cause bloating or gas.
Yeah.
I guess that's
you don't want
preparing
that
for
clean, close
everything,
space,
right?
yeah.
Another risk in space is it's very easy to get disorientated, especially when it's dark and all you can see is a few handrails, right? How can they prepare for that?
Right. So next to each handrail, there is a little arrow pointing to where the airlock is. So you just follow that thing quickly. It's really hard because, for example, if there's micrometeor that punctures a little hole, that doesn't just make you lose pressure. The gas will spin you up. You will go crazy, and it's not something that's very easy to imagine. Trying to keep you cool in that kind of situations and knowing which way is up it's too much to ask. So people put in all this little bit of extra to help them out a little bit. Yeah.
And talk to us about the robotic arms, because a lot of the spacewalks operations revolve around robotic arms. A lot of them rely on robotic arms. What can they do for future missions?
Right. So for China's robotic arms, from the designing stage, they demanded that it can reach everywhere on the surface of the entire station. So obviously, that had in mind possibility of future purely robotic things, because you have to go out quite often. There's experiments on the outside.
All right, I think we're getting that exclusive footage now for the spacewalk. This is the panoramic view. This is the view of the airlock. That is the entrance where the astronauts will be using to get out of the space station. This is Wang Yaping staying inside the core module, right? She will be staying inside to assist this mission, and the 2 astronauts are inside the airlock now. Looks like they've all suited up. This is from earlier, a short while ago, just before they embark on that spacewalk. And that's the flight control. And of course, this is a collaboration between ground crew, flight crew, cabin members inside the vehicle, outside the vehicle. Right, this is a shot of what's inside the airlock right before the 2 astronauts make their way out of the space station. They're wearing different colors of spacesuits as well, if you pay particular attention to it. I think there's a red stripe suit. Well, this is the helmet camera showing you their hand. That's the mirror on the wrist I was talking about. This is right in front of the hatch.
开始大流量冲洗完毕。
Okay, so this is some of the
无
preparation
电台手
procedure
柄
before
放到
they
大
go
流量
out.
冲洗，同时计时，两边灯亮。
I believe Jiajigan is in the right, on your right in that red striped suit, and Ye Guangfu is in that yellow striped suit.
安装绞线构型开始。
There is a critical step before going out for a spacewalk. It's called breathing pure oxygen and purging the nitrogen from your blood, right? Talk to us about it.
That's to prevent something called decompression sickness. As I said earlier, to make it movable, the inside pressure is only 40% of the atmospheric pressure. So to get from the usual inside of the station 1 bar to 0.4 bar, you drop the pressure. It's like scuba diving resurfacing. So you don't want to do that too fast. Otherwise, the nitrogen dissolved in your blood becomes air bubbles that
Whoa,
block
there we
arteries.
have it. The door
Yeah.
is now open. You can see space out there. That is Ye Guangfu preparing to go out of the airlock. That's the handle, assistant handle, helping him to open the door. Remember, back in 2008 for the Shenzhou 7 mission, they don't have that handle. And Jiajigang actually had a very hard time opening that door because of the
Yeah.
pressure difference, right?
Yeah, there's a little bit of residual air pressure inside, and they underestimated how much he can actually pull with a spacesuit on.
Yeah, and now they've made improvements. So Ye Guangfu is coming out of that airlock while Jiajigang is waiting in line. Ye Guangfu will be stepping onto that robotic arm. Now, in front of him, you can see that white structure there. That's the end of the robotic arm. And behind him, or on your right, is the working station. He is waving to the camera with the sun shining through. A breathtaking image there, incredible. And he's saying, I'm out, I feel fine. And ground crew is saying, copy that. We can hear a round of applause from the ground crew, a celebratory moment, critical step as well. Now he is floating, but he is tethered to that handrail. And like we mentioned earlier, while in space, everything needs to be tethered all the time, right? The tools,
Yeah.
devices, the astronauts.
Yeah, you don't want to float off. In the American version of the spacesuit, they have a little compressed gas to help you get back. But as I said earlier, once you push the gas out, it really makes you spin. So how much of that is actually useful?
Right. That's
Fortunately, that has
questionable.
never been tested. I don't think people really want to test it.
And earlier we see that Ye Guangfu was holding some kind of devices, probably the foot restraint, because when working in weightlessness, it works better if your foot is being put into a foot restraint, just like skiing or snowboarding.
Right.
So every time they come out to conduct spacewalk or operations, they will bring that foot restraint with them. And let's see this time what they will do with that foot restraint, because for the last spacewalk, they actually installed the foot restraint onto the end of the robotic arm, and Jiajigang was tethered to that robotic arm using that foot restraint. And this is a screwdriver, I believe.
Yeah. What?
Yeah. Every time they will bring several devices, tools
北
with them.
京机械臂运动至上臂点，指令发出，机械臂运动开始。
Okay, that's the command from ground crew saying that the robotic arm will be getting into position. And this time will be Ye Guangfu tethered to that robotic arm, and Jiajigang will be crawling.
Right.
The last spacewalk, it was Jiajigang who was tethered to that robotic arm. There you go. He stepped on that foot restraint. And it's very difficult to step on it, actually, because you cannot see that clearly. He cannot even see his foot, so he's going to have to rely on some help from his partner out there, pointing some
Right.
directions.
But on the other hand, they train so much on Earth.
That's
like,
true.
It's second nature.
That's true.
Yeah.
Been trained thousands of hours for that.
动3，请
He's
确认
unhooking from the
安全
space
带
station
与
and hook
舱
on
体之间
to
进
that
入连接。舱外
working
操作
station.
台转至身体左侧，完毕。
Yeah, these are not only very brave people; they're very patient people as well.
Right, because everything moves slowly in space, right?
Yeah, you don't want things to move too fast.
Yes,
Yeah,
yes.
if the robotic arm moves too fast and then you hit somebody else, then
That could be
guy is gonna
disastrous. This is
fly
devastating.
off,
Yeah. So everything is strictly monitored and controlled so that it can be a safe operation for the two astronauts. They cannot afford any tiny mistakes. That could
Yeah,
be deadly.
there's no remedy for any.
Right.
Yeah.
It was
神舟13
getting
号
dark.
机械臂已运动至接受
Remember,
点
this is a
2，
highlight we're showing you from the earlier
可以出舱
spacewalk.
完毕
The entire spacewalk lasts about 6 to 7 hours, but we are showing you a compact highlights. We're just showing you some of the most breathtaking moments of that spacewalk. I believe this is Zhai Zhigang coming out from the airlock. He's turning on his helmet light out there, also waving to
Yeah.
the camera.
Yeah, from this you can actually tell how slow they were moving.
Yeah.
Like,
The sun has already.
yeah, where's my sunset?
Set.
It's already it's
They've
completely dark all
experienced
of
a
a sudden.
feel
Yeah.
space station sunrises and space station sunsets, I guess.
Exactly. Yeah.
So, what would you be particularly looking at for the space station? Which part do you think is the most exciting part that worth noting?
Well, personally, I'm an astronomer, so this station has a lot of astronomy kind of experiment. There would actually be a separate module called CSS, Chinese Space Station Telescope. They'll be flying in the same orbit. It would not be attached to the space station. Otherwise, the space station is going to block the view. But it will fly on the same orbit, slightly away from it. Once in a while, you come in and you can. They can perform the spacewalk to go in there, refuel it, and do the repairs or upgrade it, hopefully. And that thing it's essentially a Chinese version of Hubble, but with 300 times the field of view, so you can collect data more often, and you can look for things that something called transient sources that just blow up instantaneously. So you don't have enough time to move things very slowly to point towards it. If you have it already in your field of view, it's a lot easier. So that'll be quite important.
So, this is the Xuntian telescope you were saying, right?
Xuntian is the Chinese word for a sky survey. That's what it means by having
That
a large
will
field
be
of view.
launched after the space station is completed.
Yeah, 23, 24. That
Yeah,
kind of
many
time.
scientists, engineers are super excited about this.
Yeah. So if you remember, Hubble had problems with its optics, and they have to remedy that. Fortunately, when they had the space shuttle, and this time, if anything needs doing, or I'm hoping they can build it larger. They can build one possibility. It's not under consideration, but one possibility is you can launch a lot of different mirrors and have them focused. Have a focal receiver on the space station itself,
Right.
then you have an enormous, essentially enormous telescope. So the possibility is endless. Yeah.
Well, it looks like we are having a good mission as of now. Do you think we're going to have more spacewalks for the Shenzhou 13 mission? I mean, this is the second one already.
Seeing how training-centric this one is, the third one may, in my opinion, probably wouldn't happen. But you never know. Somebody on the ground crew might say, my thing on the checklist is very, very important. Is worth another go,
Right.
because those spacesuits they can only be used for 15 times. You don't want to waste them.
Right.
So only for critical tasks. But as I said earlier, anything that contributes to safety is a critical task.
Right.
So it depends on a lot
Yeah.
of different
Well, they are more than 2 months into this mission. They will be staying, for the entire mission as 6 months or so. They'll be spending their New Year up there. They will be spending their Spring Festival up there. So we wish the astronauts a Happy New Year in advance. Thank you very much, Professor Zhang, for staying with me. Appreciate it.
No, my pleasure.
Now, the Chinese mainland reported 158 new locally transmitted COVID-19 cases on Saturday. 158